Right, we've got the main players of the game now. We've got the sphere and we've got the tray. I shall just rename this sphere ball. Now, we want this ball to fall into the tray from above, because I think that looks quite cool. So in order for it to fall under gravity, we need to attach a rigid body component to the ball. So I'm just going to add component, and then we've got physics, not physics 2D this time because we're working in 3D, and we've got rigid body. Okay, so that tells us that we've got a rigid body of mass 1 unit falling under gravity. Now with this collision detection, it's a bit different from before because we want to see if something continues to be in collision with another collider. So instead of having a discrete collision detection, I'm going to have continuous there instead. Now in order to detect collisions, we need a collider on here as well. So again, physics, and we've got a sphere collider which should wrap neatly around the ball. Let's just check it and edit the collider. Okay, there's our collider. It fits perfectly. Now, in order for it to hit on the tray, right, we've already got a mesh collider here. If I take off the mesh renderer, you can see the mesh collider. It's made up of triangles. The whole thing has been triangulated because triangles have to be planes. Okay, turn it back on again. Now, again, I need the tray to detect collisions as well. So I'm going to add a rigid body to this as well. Now, as it stands, what would happen now is the ball would start falling, but so would the tray. So instead of being a dynamic one, I want it to be kinematic. Okay, so we've got this option down here, kinematic. Now, when an object is kinematic, it's not affected by external forces, so I can take off the use of gravity as well. Right, it's moved under programming control. Okay, so if we just test that, we should find that the ball falls neatly into the tray. Let's see. Right, so it does. Now, the object of this game is to guide the ball through the maze by tipping the maze. So I'm going to just go up to its transform and look at the rotation. I'm just going to transform it a little bit on this axis. So you can see the tray is tilting somewhat. So let's try playing it again. And now the ball rolls down the tray, down the slope. Okay, good. Now, what we want is a way of doing that programmatically. Let's put this back to its original -90. And we can tilt things around their axes. Now, before we go into the programming, I just want to check on something. So here we've got the tray selected. You can see we've got the 3 directions of movement. And if we look at this gizmo up here, it shows us that the green one is the y-axis, the blue is the z-axis, and the red is the x-axis. Okay. And this is different from the axes that we had in Blender, where the up direction is denoted by the z-axis and the horizontal ones are x and y. However, you have to remember that this tray was tilted through 90 degrees or -90 degrees on the x-axis. It has a different set of local axes. So what we're doing here is we're showing the global axes. But if we click on this, you should see that as for the tray, it's got some local axes. And here's the green axis, the y. Here's the red axis, the X, and now this is the Z, exactly as it was in Blender. Okay, so what we're going to do is we're going to tilt. This is the forward globally. So if we tilt it around the X axis, it moves backwards and forwards according to this pattern. If we move it, rotate it around the Y, the Z, yes, the Y axis here, then it should rotate from side to side. Okay, so the next step is to actually do the programming.